Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about sedimentary environments and sedimentary rocks. So the next topic we need to think about is how do we actually weather rocks to form things which we refer to as clasts. And this is going to correspond to section 7.3 of your textbook. So to begin with, let's think about sedimentary rocks for a second, and they can be split into two broad groups, clastic and non-clastic. So clastic sedimentary rocks are sedimentary rocks that consist of pieces of rocks or minerals, and each one of these pieces is referred to as a clast. So a classic example would be something like a beach sand. So pick up a beach sand, rub it between your fingers, every one of those sand particles is considered to be a clast. And if we take that sandy sediment and we liquefy it, we turn it into a sandstone, that sandstone would therefore be classified as a clastic sedimentary rock. So if your sedimentary rock contains clasts, it's going to be clastic. So how are we going to make these pieces of rock in the first place? Well, obviously we're going to need to weather pre-existing rock to produce these clasts, which can then be transported. So what we're going to do is we're going to look through a few processes that will actually allow us to make clasts. Once again, this isn't going to be a complete overview. This is just going to be focusing on some of the main processes which actually lead to clast formation. So you can see in this image we have an area of rock, and we can see that it's being eroded through various methods. So the first method through which a rock will break down is simply through fracturing. So fracturing can be due to relatively simple processes such as landslides. So the process of a landslide can cause rocks to break, but it is most commonly associated with the process of uplift. So if you imagine that this piece of rock was underground, let's say it was buried 5 kilometers down, so quite deep, and in that environment it's going to be under lots and lots of pressure, so it's going to be squished. Now, as the rock gets uplifted and pushed towards the surface, the pressure is going to drop. The rock is therefore naturally going to expand, and as the rock begins to expand, it is going to crack. And so fracturing in our rock can be produced by a number of different processes, but the fractures that form will then typically be exploited by other weathering processes, and these weathering processes will then weaken the rock and cause it to fall apart. So one of these other processes is something which is referred to as frost or mineral wedging. So what's frost wedging? Well, frost wedging occurs where we have a crack in our rock, and during the day, when the temperature is above 0 degrees Celsius, there is liquid water moving along the crack, or entering the crack in some way, maybe from the soil. Now, during the night, the temperature drops below 0 degrees Celsius, so that water freezes. As we know, water when it freezes increases in volume. And so the water that's trapped in the crack here all of a sudden begins to expand in volume, and so it starts pushing the pieces of rock either side. And so every day you have the water filling up the crack during the day and then freezing during the night. And so every day you have this expansion, contraction, expansion, contraction, and eventually it weakens the rock and it causes the rock to fall away. Mineral wedging is a similar process. It's caused by water moving along the crack again, but as the water is moving along the crack, it starts to deposit minerals. And so this means that as more and more minerals get deposited in the crack, well, that essentially helps to push the crack wider and wider as more and more minerals get deposited in there. And so once again, that's eventually going to lead to a piece of rock coming away and forming a clast. So there's obviously going to be biologic activity which is going to lead to rocks falling to pieces. And the classic example of this would be roots related to trees and bushes. So a tree is going to essentially try and exploit any kind of crack it can find to put a root in for a couple of reasons. Number one, having a root in that crack is going to help to stabilize the plant. But number two, these cracks tend to be the location along which water gets focused, and so if you have a root inserted in that crack, it allows you to access that water. Of course, the thing is over time, as your plant gets bigger, the roots are naturally also going to get chunkier. And so as your roots begin to increase in diameter, they're obviously going to put more stress on the surrounding rock, and they're going to force the cracks open. They're going to cause the rock to break up. So, you know, if you guys have been out into hill country to the west of Houston, you will have seen, you know, lots of trees in relatively shallow soil, and you might have seen that these trees have their roots, you know, buried deep down into the exposed rock via the cracks. There's also going to be other biologic activity which is going to help to break up the rocks. So that would be, for instance, burrowing organisms. So burrowing organisms will obviously affect the sediment typically where you have the soil in contact with the rock. So along the interface between the soil and the rock, you're going to have lots and lots of fragments of rock mixed in the soil. If you have a burrowing organism moving through the soil, it's going to take these larger pieces of rock which were down at the bottom, and it's going to push them towards the top. So they're going to be pushed towards the surface where they can then be transported away in the sediment. The final method through which we can make our rocks break through physical weathering is going to be thermal expansion. And this is simply produced by the rock being heated up during the day and then the rock cooling down and contracting during the night. So your rock is expanding, contracting, expanding, contracting. The thing is your rock will not expand and contract in a nice uniform way. And because the expansion and contraction is heterogeneous, that means you're going to get pressures building up in different areas of your rock, and over time these pressures caused by the expansion and contraction of your rock can cause your rock to fall to pieces. So these four methods that we've described are referred to as physical weathering because it's a physical process which is allowing your rock to break up. So the next processes through which we can break up our rock is chemical weathering. So chemical weathering, as the name suggests, is going to involve chemical reactions. So what are some of the methods by which chemical weathering can affect our rocks? So the first method is dissolution. So the vast majority of water which is moving around on the surface of the earth is slightly acidic. And so this means if your slightly acidic water comes into contact with a rock which is slightly alkaline, let's say something like a limestone, there's going to be a chemical reaction because you have the acid water and the alkaline rock, which is going to be your base. So you've got an acid-base reaction, if you remember that from high school chemistry. And so the chemical reaction is going to dissolve the rock, and the constituents produced are going to enter solution in the water. So they're going to dissolve in the water and be transported away. Now, one of the things about dissolution is that it obviously has to occur in areas where we have water flow being focused. So if we just go back to our previous slide, you can see that we have a situation where we have a rock that's full of fractures. This is where the water is going to primarily be focused. And so this means over time dissolution can take place along these fractures. It will weaken the surrounding rock and allow it to fall apart into larger pieces, obviously, which are smaller pieces which we refer to as clasts. So the next process is hydrolysis, and hydrolysis is a chemical reaction between minerals and water. So there are lots of minerals that don't like being around water, and when one of those minerals comes into contact with the water will begin a chemical reaction with it, and the mineral will begin to break down, and typically that mineral will break down to give us clay. And of course that clay can then be transported away, through processes such as the movement of water or the movement of the wind or ice, for instance. So hydrolysis is a very, very common chemical weathering process because silicate minerals are extremely common in the Earth's crust. Then we have the process of oxidation. Now this primarily occurs with minerals which actively react with the oxygen in the atmosphere, and the primary group would be iron minerals, especially iron oxide minerals. So these minerals will come into contact with the oxygen in the atmosphere, there will be a chemical reaction, and it will end up forming, for want of a better way of describing it, rust as part of the process. And of course there are going to be chemical components liberated as part of this chemical reaction. They will dissolve into the soil, they will dissolve into water, and then over time they will be transported away. So essentially these oxidation reactions, once again, they're a process of weakening the rock, and then that allows the rock to fall to pieces and then be transported away in the form of clasts. The final kind of chemical weathering is biological reactions, and biological reactions can take a number of forms. So, for instance, there are certain species of bacteria that will actively break down rocks. There's also the types of biological reactions associated with decomposing organic material. So when this plant dies, it will decompose, and that will often produce quite acidic fluids as part of that process. And obviously these acidic fluids can then react with the rock and cause it to chemically weather. There's also an effect from living plant material. So it's not uncommon for plants to try and defend themselves by covering, for instance, their roots in a layer of material which offers them some kind of protection. And so this material, this solution which they cover their roots in, can in some cases be slightly acidic, and so you can have a reaction between this material that's covering your roots and the rock through which the root is passing, and once again this can lead to a chemical reaction which causes the rock to break down. So you can see that rocks can be broken down via either physical or chemical weathering, and this is going to result in the formation of clasts, so pieces of rock. And of course, as we know by now, these clasts can range anywhere in size from massive boulders all the way through to tiny flakes of mud. Obviously then we also have chemical reactions in some cases, and this will result in rocks actively dissolving and the resulting constituents being transported away in solution in water. Alright, thank you for watching everybody, and have a good day.